Okay, so we will be discussing another method in finding the integrating factor of non-exact equation. Suppose lambda is an integrating factor of the equation m dx plus n dy equals 0. Now, the partial derivative of lambda multiplied by m with respect to y is equal to the partial derivative of lambda multiplied by n with respect to x. Also, multiplying the whole equation by lambda will make the equation exact. Now, we discussed two theorems, no, that determines the integrating factor of the equation if 1 over n multiplied by the difference of these two partial derivatives is equal to a function of x alone, then the integrating factor will be evaluated by this formula, e to the integral of g of x dx. Note that g of x can be constant. Now, if the first theorem is not satisfied, then we can apply theorem number 2. So, still the difference between the two partial derivatives multiplied by 1 over m. And this time, if the equation is a function of y alone, then the integrating factor would be evaluated using this formula, e to the negative integral of h of y dy. Hy can be considered as a function of y alone. Now, if the two previous conditions are not satisfied, it only means that the integrating factor is a function of x and y. So, the previous theorems are only applicable if the integrating factor is either a function of y or a function of x alone. If the given equation is a homogeneous equation, okay, this is your integrating factor, provided that the denominator is not equal to 0. And if for some non-homogeneous, if m can be written as y times a function of xy, and n is equal to or can be expressed as x times a function of xy, then you can find that the integrating factor is 1 over xm minus yn, provided also that the denominator is not equal to 0. Okay, so let's solve this example. Okay, we solve this equation. You can verify that this is a non-exact equation. Okay, so we can take this as your m, and then this can be expanded as x squared plus 4xy minus 2x, so that will be your n. And then applying theorem number 1, 1 over m, and then the difference of their partial derivatives. So the partial derivative of m with respect to y, so x is constant. So derivative of xy is x. Derivative of 1 is 0. And then partial derivative of n with respect to x, y is constant. So x squared, the derivative is 2x. 4y is constant, derivative of x is 1, so you have 4y. Derivative of negative 2x is 2. And then simplifying this, okay, so this is minus 2 minus x, okay, minus 4y, and then plus 2. Observe that if you factor out negative here, that will give you positive x, positive 4y minus 2. So therefore you have negative 1 here, so this will just cancel out. But you have a negative 1 here, and then x. So therefore, this is a function of x alone. The first theorem is satisfied. Then you can compute for lambda using this formula. So e to the negative 1 over x, this is your g of x, e to the negative ln of x. So you can place it here, e to the ln of x raised to negative 1. And then note that when you have e to the ln of u, okay, that is equal to u. So therefore, your integrating factor must be x raised to negative 1. Okay, now if this is your lambda, your integrating factor, okay, so multiplying m and n by lambda will make the equation exact. So no need to verify. And then I'll be using line integral. Okay, but take note that this one is y plus x raised to negative 1. So x cannot be, this is 1 over x eh. So x cannot be equal to 0. So we can change the lower limit to 1. Okay. So I'll be using mx0. So y is equal to 0. And that gives you x raised to negative 1. And then copy, this one is x plus 4y minus 2, no? This, because this one is equal to 1. So x plus 4y minus 2. And then integrate, this one is ln of x, 1 over x is ln of x from 1 to x. And then integral of, with respect to y, so x is constant, so integral of 1 is y, and then 4y squared over 2 is 2y squared, negative 2y, okay, negative 2y, from 0 to y, y, then 0, when y is equal to 0, so 0, 0, 0, so the same, xy plus 2y squared minus 2y, ln of x is ln of x minus ln of 1 is 0, and therefore this is your general solution. Okay, let's have another example. Okay, we try. So m here is xy plus y squared plus y. Your n here, this is your n, x squared plus 3xy plus 2x. Now, using the first theorem, okay, so this is 1 over x times x plus 3y plus 2. Okay, partial derivative of m with respect to y. So we have x here, y squared is 2y, y is 1. Then minus partial derivative of n with respect to x. So minus 2x, okay, minus 3y, x is 1, and then minus 2. And we can simplify this as negative of x plus y, okay, plus 1. Okay, and then as you can see, we cannot simplify into a function of x, no, alone. Therefore, we can proceed to theorem number 2. So this time the same difference of derivatives, but this time we multiply by 1 over m. This is the difference from the previous, from theorem 1. So we get negative x plus y plus 1, and then 1 over n. This is your 1 over n. Okay, so this will cancel out, giving you negative 1 over y. So negative and then negative positive 1 over y, e to the ln of y. So this is your integrating factor. Okay. And then multiply the original function by your integrating factor, which is y. Okay, so you use the line integral. Both are continuous, no, at x equals 0, y equals 0. So we just copy your m. This is your m, your new m. So xy squared, y cubed, and then y squared. And then here when x is equal to 0, this is x equals 0, so everything will be 0. Okay, so the second term is now 0. We just evaluate the first term, no? So with respect to x, so y squared is constant, so copy. Integral of x is x squared over 2. Y cubed is constant, copy, so multiply by x. Also y squared, so multiply by x. From 0 to x, so x are same, minus 0, so minus 0, minus 0, minus 0 when x is equal to 0. And then simplify, multiply by 2. Okay, the whole equation will give you your general solution.